I am talking about not aspirin, but ibuprofen and paracetamol, otherwise known as Tylenol. As you can see, ibuprofen is very similar to aspirin in function, how it stops cyclooxygenase. Biggest difference is that it's reversible, and it's processed by the kidneys as opposed to the liver. And the structural difference you see is this isobutyl, we just know is the carbons, 1, 2, 3, 4 carbons. They come up here instead of another alcohol group, and it's bulky, so it takes up more space, and it's hydrophobic because these are hydrocarbons, and it's more of a temporary block of COX, cyclooxygenase, versus the acetyl group of aspirin, which is an irreversible group. So the temporary nature of this is vital in knowing that if you are going to be bleeding from your brain or have a surgery or otherwise, this could save your life because this is a temporary block of COX enzymes. Because antiplatelets and thromboxane are important, like we talked in the other video, that this could save your life in that it's more manageable because you could take just a bit of this all the time versus one aspirin that would function. And also, aspirin has been known to cause Rey syndrome via its interference with mitochondrial fatty acid oxidation, because aspirin has a unique pattern on the electrotransport chain, and that's about it for here. But that's the isobutyl, this one functional group, changes everything for ibuprofen, which is more of a bulky, it's like putting a boulder on something that you can move again, while aspirin is more of like it's welded shut, like a door. It takes more effort, but over here is paracetamol. Paracetamol is more complex, and it's not actually an NSAID at all. It works more on the cyclooxygenase 3 and on the central nervous system, as opposed to the peripheral nervous system that ibuprofen and aspirin do. The hypothalamus is controlled to turn down the volume of the thermostat. That's the key idea of what you should remember what Tylenol or the paracetamol does. So the alcohol group right here is the cyclooxygenase inhibitor by redox interference. So it doesn't block it like this part does, the ibuprofen or the acetyl group of the aspirin. This uses electron donation. You should think of electron donation to shut down prostaglandin, because where there is low peroxide in the brain and hypothalamus, there the donation of electrons, and it doesn't see the need to make prostaglandin the way it does. But it doesn't work. That mechanism is important because it doesn't work in the peripheral nervous system where peroxide is in the tissues. So peroxide would be donating electrons, and this is the mechanism. So this works more on electrons. Tylenol works more based on the alcohol donating electrons. The ibuprofen works more as a big boulder, blocking the COX enzymes temporarily, while aspirin would be the acetyl group. Looks more like this. The acetyl group that holds on to it and as a bolt lock, a door that's bolted shut. That's the main difference that you could think of. So maybe I could find that. Um, let's see, rock. I'll put this one because it's funny. So would be this would be ibuprofen. All right. Uh, Not the doors. Uh, the thing completely being shut down forever would be the aspirin. So this aspirin which was before. This would be, oh well, this would be the ibuprofen just being in the way. It can easily movable. Just ask nicely or wait a little while. While we'd use the star. Why not? The star would be the Tylenol because it's electron based. But in terms of how the electron donation is used to stop prostaglandin need in hypothalamus to turn down the temperature of the central nervous system, so in the brain, it works with AM404, so arachidonylophenolamin and anandamine through the endocannabinoid system. So you can think of ganja in terms of what it actually does, where it's working on. That's the name for a reason. And so this would be an inhibitor of the endocannabinoid transport, so it keeps it there. And that's this right here, the AM404, so arachidonylophenolamin. So these chains are what keeps its function, so it gives it its function. So this is what's recognized by the endocannabinoid transporter, so the cannabinoid system. So this is the actual cannabinoid. So anandamine is an actual cannabinoid. So you can use your imagination to make this ganja, but its meaning is bliss, its literal meaning in Sanskrit. The bliss, we call it the bliss, reduces neurotransmitter release, glutamine in the pain pathways, and makes dorsal horn neurons less excited. So it's a dampener of pain and even fear via the amygdala. And on top of the hypothalamus temperature control, AM404 just blocks the bliss from being taken away. So this keeps this star chills out the need for prostaglandin synthesis in the brain and the hypothalamus, even the spine, and this keeps it around. So this, you can think of this keeping this electron from this group, keeping this around in the brain and making you chill out. But the long poly chain unsaturated chain, so these chains, 20 carbons with double bonds, so unsaturated meaning double bonds, are what keep this connected to the cannabinoid receptor 1, and the double bonds just keep it flexible. The amide, so this nitrogen, keeps it short-lived by being broken down like an off switch built in. And that's what I wanted to show for today. So remember, this is aspirin. It's a complete block. It should be next. It should complete block. While ibuprofen is a big, sluggish, temporary block. You can think of it staying there and walking away. It's temporary. This is aspirin would be irreversible. It's important because it could kill you if you are having surgery or bleeding somewhere. If you're in contact sport or something. While paracetamol, Tylenol, would be electron-based from the alcohol group that keeps this around via this transporter being used on the transporter receptor being used to keep this around, which this would keep you chill in your brain in terms of how like ganja would work, in literally the same system. And it dampens pain, fear, and your temperature, which is the most important and noticeable one. And it's done because the nitrogen is temporarily what reacts and is broken down by hydrolysis. And this chain is what's recognized by the endocannabinoid system. So it's recognized almost like weed. So yeah, there you go. Thanks.